Welcome to the debate. Our focus today, well, it centers on a technical document, but one with the pretty provocative title, actually. It's published by Hugging Face DB and called The Small Training Playbook: The Secrets to Building World-Class LLMs. Now, that title, it really sets up a confrontation, doesn't it, with the current thinking that you need absolutely massive scale for top performance. So we have to ask, is this playbook, this small training idea, a genuine signal of a paradigm shift? Can smaller models really achieve world-class capabilities through efficiency and better methods? Or is this mostly, sophisticated optimization, maybe some rebranding, that doesn't fundamentally challenge the need for huge scale? I'll be arguing that small training, at least as it's framed here, fundamentally redefines the best path forward, prioritizing innovation over just raw compute power.
And I come at it from a different angle. I have to just say, I remain deeply skeptical. Optimization is crucial. Yes, absolutely essential. But I'll argue that absolute scale, sheer size, is still the unavoidable bottleneck for what the industry has empirically defined as world-class generalized performance. This material, it forces us to grapple with a really key tension. Can clever methods truly overcome the sort of physics of information processing? Or, is compute still king?
I see why you think that, but let me give you a different perspective here. Just look at the language the authors chose. The title isn't like Tips for Better 7B Models or something mundane. No, it's The Small Training Playbook. It's declaring that the methodology, the systematic playbook, and the efficiency, the small training, these are now the primary factors for getting state-of-the-art results. It kind of dethrones simple parameter count, doesn't it? It's a thesis suggesting, well, that intellectual capital can potentially trump financial capital, and using the word secrets, that strongly implies the critical path isn't how big your cluster is, but rather conceptual breakthroughs. Things like, radical advances in data curation, or maybe architectural tweaks that kind of defy the old scaling laws.
If a major player like Hugging Face TB is promoting this as a route to world-class LLMs, well, we have to take seriously the idea that really targeted, efficient training can achieve utility rivaling models 10, maybe 20 times larger. This isn't just tweaking things. It feels like a democratization of high-end AI, shifting power away from the few labs that can afford those massive petascale training runs.
That's a compelling narrative, I grant you, but I find myself deeply unconvinced that we can just redefine world-class to mean something other than what we've seen from the frontier models. I'm sorry, but I just don't buy that a significantly smaller model can genuinely compete head-to-head with something having hundreds of billions of parameters on, general capability. Historically, world-class meant matching or beating the biggest LLMs, the ones showing those emergent abilities like robust zero-shot reasoning, or deep complex code generation, or handling these massive multi-million token contexts. When we talk small training, typically we're in the, 3 to maybe 8 billion parameter range. The performance gap between an 8B model and a 100B plus model on generalized abstract tasks is frankly huge. It's dictated by scaling laws that are pretty well established now. So I suspect this playbook, it's more likely focused on achieving world-class performance within a specific niche, or maybe world-class relative to the resources used, which, look, that's a vital engineering goal, especially for deployment, absolutely. But it's not, I don't think, a revolution that replaces the fundamental need for scale to get that absolute generalized intelligence. And that brings us neatly to our first core contention, really. What does world-class truly mean in the context of this specific playbook? You argue for shifting towards utility metrics, but when LLM researchers talk about scaling, they're chasing generality. They're following things like the chinchilla scaling laws, right, which predict performance keeps improving pretty linearly if you increase both parameters and training tokens together, and we're talking trillions of tokens.
For your argument to hold, the advocate this playbook's methodology must somehow fundamentally break those scaling laws. How does an 8 billion parameter model, even if trained incredibly efficiently, suddenly gain the sheer breadth of knowledge and the generalized reasoning power that currently seems restricted to models north of 100 billion parameters?
That's an interesting point, though. I would frame it differently. And I think focusing so heavily on historical scaling laws, well, it kind of misses the crucial economic and technical context right now. Yes, okay, for pure, abstract, generalized cognition, scale is currently king. Fine. But what percentage of actual real-world use cases demand that absolute, theoretical peak performance? I'd argue that world-class is rapidly evolving. It's shifting to mean something more like optimal utility per unit of cost or resource. We're moving, I think, from just measuring raw output to measuring efficiency. Think about it. If a model built using this small training playbook can handle, say, 98% of specialized enterprise tasks, runs locally with super low latency, and slashes deployment costs by 90%, well then, that 100 billion parameter behemoth, with its huge inference costs and deployment headaches, is arguably less world-class from a practical end-user standpoint. The paradigm shift is redefining the performance ceiling. It's not about theoretical maximum knowledge anymore, but about deployable, cost-effective knowledge. The industry bottleneck isn't just training the model, it's deploying it affordably and effectively at scale. And this leads us right into the second point of contention, the significance of calling it a playbook and mentioning secrets. If you stick rigidly to the old scaling laws, you basically dismiss the possibility of major algorithmic innovation, right? But calling this a playbook implies a systematic, repeatable process. It suggests the secrets, the key knowledge, can help bypass those huge capital costs. Now, what might these secrets be? Well, they could be things like groundbreaking advances in really granular data curation, where the training data quality is so high, so targeted, it packs the punch of a much larger data set. Or maybe architectural secrets, novel tweaks to attention mechanisms, perhaps? Or maybe a sparse or a localized mixture of experts set up that's tailored for efficiency, letting smaller parameter counts work more effectively. This fundamentally changes the barrier to entry, doesn't it? From needing massive infrastructure to needing intellectual ingenuity.
Okay, I understand the appeal of, brains over budget, the intellectual ingenuity conquering capital. But I'm not convinced by that line of reasoning, because it seems far more likely that the secrets detailed in this playbook are, just best practices for optimization. Very good ones, perhaps, but optimization nonetheless, rather than truly disruptive science that rewrites the rules of information capacity. For instance, think about it. Many successful small models rely heavily on distillation, right? They learn from a foundational, massive, and very expensive teacher model. So if the playbook details highly efficient ways to distill that knowledge down, maybe using techniques like QLoRa for effective quantization or advanced data filtering to ensure the smaller model learns only the highest quality signals, these are fantastic engineering wins, no doubt, but they're still fundamentally dependent on the existence of that big, non-small parent model. I mean, if the secret is something like advanced quantization, like QLoRa, sure, it's a brilliant way to squeeze a large model's weights into a smaller memory footprint for inference. Absolutely useful. But QLoRa doesn't magically increase the inherent knowledge capacity of the base model. It just makes the compression better. If you fundamentally need, say, 100 billion parameters worth of complexity to truly master advanced physics or nuanced legal reasoning, no amount of training efficiency or clever distillation can create that foundational knowledge within a 7 billion parameter structure. We really need to clarify, is this playbook about training a small model from scratch to be world-class? Because that would be revolutionary. Or is it about how to optimize, fine-tune, or distill existing small models to maximize their utility, which is crucial, yes, but evolutionary, not revolutionary? I strongly suspect it's the latter.
Well, okay. Even if we accept a heavy reliance on distillation, and I'd concede, yes, that's a common technique to bridge the scale gap, the efficiency gained through the methodology itself still represents a kind of paradigm shift. The innovation is in the process. The efficiency of knowledge transfer, the optimization of resource use. That's becoming central. Achieving world-class utility today, arguably, means mastering deployment and efficiency, not just mastering the initial training run. And furthermore, let's touch on the final contention, the role of the platform itself. The fact that Hugging Face TB put the small training playbook in a Hugging Face space, that's not just a neutral choice, is it? It feels like an ideological statement.
This delivery method, it really underscores a belief in community sharing, rapid iteration, open accessibility, values that are just intrinsically tied to the whole small movement.
It positioned this knowledge outside the closed doors of big corporate labs, makes the secrets potentially actionable for any developer with, reasonably modest hardware. The platform's choice itself kind of reinforces the whole idea that innovation can be open-sourced, driven by collective effort, validating the premise that high performance might be unlocked through shared knowledge, not just proprietary compute advantage.
I come at it from a different way regarding the platform. And here's where I think we need to separate let's say, the ethos from the empirical claim. Look, I deeply respect Hugging Face's community focus. It's absolutely foundational to modern open AI research. But the choice of platform, however laudable, doesn't inherently validate the world-class claim being made about the content. The space is just an incredibly efficient way to host and distribute the technical document. It democratizes access to the playbook, sure, but it doesn't magically confirm that the methodology within actually dethrones the reality of those massive multi-trillion token training runs done by labs with near unlimited budgets. It's a brilliant strategy, certainly, targeting developers who are hungry for efficiency. But we have to be careful not to confuse the accessibility of the documentation with the absolute technical feasibility of matching genuine frontier performance.
Think about it. If this playbook lets a startup build a highly optimized, domain-specific model that runs on an edge device for, say, $1 million, fantastic, that's a huge win. But if a competitor can still spend $1 billion on a much larger model and achieve true zero-shot generalization across 30 different domains or modalities, which path is really defining the absolute frontier? The small training approach, as described, seems to be defining the frontier of practical deployability, and that's incredibly important. But raw scale likely remains the frontier of generalized capability, at least for now.
Right, but regardless of where that absolute theoretical frontier lies today, the very existence and promotion of something called the small training playbook forces the entire research community to shift its focus or at least broaden it. It demands we rigorously prioritize innovation that drives efficiency outside of just climbing the scaling curves. Whether these small models ultimately achieve the absolute peak of generalized reasoning is maybe becoming less important than the simple fact that they are redefining what useful and deployable performance looks like for the vast majority of users and businesses. The conversation, I think, has decisively shifted. It's moving from just how large can we possibly make it to how small and efficient can we make it while maintaining truly world-class utility. That shift in objective, to me, defines the new paradigm.
I agree that optimization and utility are absolutely essential, and the efficiency gains from these kinds of methods represent a massive victory for practical deployment. However, if we're going to take the claims in the source material at face value, that term world-class LLMs really needs critical, nuanced definition. If we let it simply mean efficient and useful for specific tasks, we risk diluting its meaning compared to frontier research, which, let's face it, is still driven by the perceived necessity of massive scale to unlock true generality and those unpredictable emergent behaviors. The burden of proof, I think, still rests squarely on these efficiency methodologies, the ones presumably in the playbook, to demonstrate they can truly match generalized, large-scale performance across the board. And until that empirical evidence is really overwhelming, scale, unfortunately perhaps, remains the dominant factor for achieving absolute capability.
So this brief look just derived from the title and concept of the small training playbook clearly highlights a crucial divergence in how people are thinking about LLM development. It's this tension between knowledge efficiency, the small approach, and raw brute force scale. It's a divergence that definitely warrants continued close examination of the technical details within the material and, of course, its real-world impact.
Hey, welcome back. Today, we're cracking open something the entire AI community is buzzing about. It's called the Small Training Playbook, and it's supposed to hold the secrets to building world-class large language models. Okay, let's just dive right in.
So let's start with the billion-dollar question, right? How do you actually build one of these incredible AI models?
How do you go from nothing to a powerful, intelligent system that can write and code and even reason? You'd probably think the answer is simple, just throw a ton of money and a mountain of computers at the problem.
But what if? That's not the whole story. This playbook suggests something totally different. It argues that building a top-tier model isn't just a game of brute force. It's a game of strategy, of know-how. It's about knowing the secrets.
I mean, for a long time, building state-of-the-art AI felt like it was reserved for the gods, up on, this LLM Olympus, the big tech giants. But this playbook, well, it's supposed to be a guide for the rest of us.
And yeah, this slide just lays it all out, doesn't it? On one side, you've got the giants with basically unlimited compute, huge armies of researchers, and trillions of data points. And on the other side, there's the aspiring builder. Maybe that's you, with a limited budget, a small, scrappy team, and a much more focused data set. I mean, the odds, they seem completely stacked against you.
But this is where our guide comes in. The small training playbook is basically being sold as the secret map for that aspiring builder. It's the tool that's designed to level the playing field, not with more cash, but with a better game plan.
Okay, so secret number 1 is all about the foundation. It's a process called pre-training, and they're super clear about this. Get this part wrong, and pretty much nothing else you do is going to matter. So, what exactly is pre-training? Picture this. You're building a monster car engine from the ground up. You're feeding this model a massive library of text, books, articles, code, you name it, and it just soaks it all up. It learns the patterns, the grammar, the facts, the very structure of human knowledge. Right now, it can't drive anywhere, but man, is it powerful.
So the playbook breaks this massive job down into 3 key pillars. First, and this is the big one, you have to curate your data. Second, you pick your model's architecture. And third, you have to be incredibly smart about how you use your computing power.
And this is where we get the first huge secret about data. It's not a numbers game. It's not about having the most data, it's about having the best data. The playbook argues that a smaller, really meticulously cleaned and deduplicated dataset will build a much stronger engine than a giant, messy, noisy one. Quality, they say, beats quantity every single time.
All right, so you've built this incredible, powerful engine. Now what? Well, now you got to teach it how to actually be useful. This next secret is all about refinement, about control. It's a process they call alignment.
Yeah, so if pre-training was building that engine, alignment is literally teaching the car how to drive safely. You're taking all that raw horsepower, all that knowledge, and you're shaping it, molding it into an assistant that's helpful, harmless, and can actually follow your directions.
And this chart, it just nails the difference, doesn't it? A pre-trained model is a raw knowledge engine. It can finish your sentences, sure, but its behavior is kind of unpredictable. But after alignment, you get a helpful assistant, something you can actually steer, something reliable.
So how do they actually do this? Well, the playbook points to a few key techniques. You've got instruction fine-tuning, which is basically just showing the model lots of good examples. Then you get into the more advanced stuff, like RLHF, that's reinforcement learning from human feedback, and another one called DPO. Look, they're both just clever ways of using human preferences to reward the model for giving better answers, teaching it what we really want.
Okay, so we've talked about the what and the how, but what's the big idea here? What's the core philosophy that's tying all these secrets together?
There is one idea the playbook just drills into you over and over and over again. You absolutely cannot fix a weak foundation later. It's impossible. All the fancy alignment tricks in the world won't save a model that was poorly pre-trained. Everything rests on the quality of that first engine.
And listen, if there's one image you remember from all of this, make it this one. When you look at what really drives a model's performance, the playbook's data is crystal clear. Data quality is, by a huge margin, the most important thing. It's way more important than just making the model bigger, and it blows raw data quantity out of the water.
And the last big piece of wisdom, it's all about keeping it simple. See, the whole small idea is about being focused, being efficient. The goal is not to build some crazy, complicated system. It's to build the simplest thing that actually works. Unnecessary complexity, that's your enemy.
All right, so we've gone through the playbook, we've peeked at the secrets, you've got the map now. So, what does it all mean? For you, for me, for the future of AI?
So let's just quickly recap the absolute key takeaways here. First, building a great LLM isn't some dark art reserved only for the giants anymore. Second, that foundation, the pre-training, it is everything.
Third, alignment is what turns that raw power into something genuinely useful. And last but not least, the golden rule. Data, quality over quantity, always.
Which, of course, leaves us with one last, really fascinating question. Now that this secret map is out in the open, is it truly going to level the playing field? Are we about to see a flood of incredible, powerful new models from smaller teams, from independent builders? The playbook's out there now. What happens next? Well, that chapter's up to them to write. Thanks for tuning in.